I want you to imagine a professional weightlifter for just a second. Picture them. They don't just walk up to a massive loaded barbell and casually try to pick it up, right? No way. There is intense focus. There is a very specific, rehearsed methodology, and then there's an explosive burst of perfectly coordinated power. Well, that is exactly how you need to approach high-yield questions on the Cambridge 9618 Computer Science exam. Today, we are running a high-intensity strategy session. We are tackling what the principal examiner reports continually flag as literally one of the most notoriously misunderstood areas of the entire syllabus. And that is the open source initiative and software licensing in general. Now, I know you know what open source is conceptually, but the exam demands something completely different. So we are going to treat this explainer like an elite training session. We're going to break down the examiner's playbook page by page so you can walk into that exam room and execute your answers with absolute undeniable precision. Here is our roadmap for today's session. We'll start with the licensing exam trap, then move into core licensing principles, break down the technical methodology, and finally wrap up with top examiner warnings. Let's get right into it. Act 1, the challenge, the licensing exam trap. Okay, let's dive into this. So you really have to ask yourself, why is the open source initiative the most misunderstood topic on the 9618 exam? I mean, it seems totally counterintuitive, right? It's a topic most computer science students feel incredibly familiar with from their daily lives. You use open source software all the time. But when we actually dig into the Cambridge Principal Examiner reports, the absolute goldmine of what not to do, a glaring, massive pattern emerges. The reports constantly, and I mean constantly, highlight a lack of systematic analysis and a complete failure to make cross-topic connections as the primary reason students fail to secure those top marks. See, students tend to treat open source as a general knowledge trivia question. They just define it. But that's not what Cambridge actually demands. Cambridge demands a complex, technical evaluation of a legal and operational framework. You aren't just being asked what it is, you are being asked to systematically analyze how it interacts with the rest of the computer system architecture. If you treat it like pub trivia, you are walking straight into a trap. To really see this trap in action, let's look at two hypothetical students facing a tough past paper question. We'll call them Alex and Sam. Now, Alex has spent hours, probably days, just memorizing the textbook. When asked to evaluate the impact of an open source license on a commercial software project, what does Alex do? Alex writes a massive page-long paragraph dumping raw facts about the history of GNU/Linux and the dictionary definition of source code. Lots of ink, plenty of sweat, but literally 0 marks for analysis. Why? Because Alex didn't answer the specific context of the question at all. They just word-vomited facts. Now look at Sam. Sam is different. Sam sees the question, feels that intense time pressure ticking away, and completely rushes. Sam writes, open source means the code is free and anyone can edit it, completely ignoring the crucial command word, which was evaluate. The examiner explicitly asked for an evaluation of an impact, and if you know your command words, evaluate requires weighing the pros, the cons, and providing a justified contextual conclusion. Sam just gave a basic IGCSE level definition. Both of these students fall right into the trap. So the absolutely crucial takeaway here is this: raw knowledge is totally useless without strategic application.
Moving on to Act 2, the strategy reveal. Let's uncover the core licensing principles.
We need a foundational reset right now. For the purposes of this exam, the open source initiative is not just free software. You have to scrub that simple definition from your mind. For the exam, you must define it as a strict legal and operational framework built on precise definitions, causal relationships, and evidence-based reasoning. When you sit down to write an answer, remember that top-tier marks are exclusively reserved for candidates who don't just say what OSI is, but who clearly explain cause and effect. Think about it like a chain reaction. For example, you wouldn't just say it's open. You would say something like, because the OSI license mandates source code availability, it causes a distributed peer review process, which directly leads to more rapid patching of security vulnerabilities compared to proprietary models. Do you see the huge difference there? You're weaving a highly technical narrative. You're integrating these core principles with other complex syllabus areas like software security and development lifecycles. That's the level of depth the examiner is actively hunting for. Now, to truly understand why we have to answer this why, we have to look under the hood of the Cambridge marking scheme itself. The assessment objectives aren't just arbitrary points. They are meticulously divided into specific cognitive domains. Knowledge and understanding, that is only 33% of the marks. Application is another 33%. And analysis, the big one, is the largest slice at 34%. Think back to our student Alex from a minute ago. Alex absolutely maxed out the knowledge slice by dumping all those raw facts, but scored an absolute 0 on application and analysis. If you only provide facts in your exam, you are literally voluntarily capping your grade at 33% before the examiner even finishes reading. Raw knowledge absolutely must be paired with application to the specific scenario they give you in the question, followed by deep, structured analysis. So you're probably wondering, how do we actually guarantee we hit all 3 of those cognitive domains every single time we pick up our pen? We use the PEAL framework: point, evidence, explanation, and link. Step 1 is point. You state your core argument clearly, directly addressing whatever command word they threw at you. Step 2 is evidence. This is where you bring in a highly specific technical fact, maybe a specific OSI criteria. Step 3 is explanation. Now, this is where the heavy lifting really happens. You have to explain exactly how your evidence proves your point, strictly within the context of the scenario. And finally, step 4 is link. You tie the whole paragraph back to the overall objective of the question. Here is the magic of PEAL. If you force your brain to follow this exact structure, it becomes physically impossible to write a purely factual, non-analytical answer. It forces you into that top mark band. Before we look at a live transformation using this exact framework, I need you to do something. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. It's the best way to ensure you never miss any of these high-intensity strategy sessions. Act 3, the transformation. It's time for the technical methodology. Let's do a quick visual rewrite exercise to see this in action. Remember Sam's rushed answer from earlier? Sam just wrote, "Open source means the code is free." Let's take that and completely transform it using our PEAL blueprint. For our point, we write, "Adopting an OSI-compliant license increases the project's long-term sustainability." Boom, direct and analytical. Now evidence. This is because OSI mandates the free redistribution of the source code. Next, the critical explanation. Consequently, even if the original development team completely abandons the project, the broader developer community can legally fork the code and continue maintaining it, which mitigates vendor lock-in risks. And finally, the link. Therefore, the commercial impact is a highly resilient software lifecycle. Just look at that difference. Seriously, compare the two. By layering in evidence-based reasoning and deeply contextualizing the impact, we've elevated the answer from a basic lower-level definition to a totally robust top-tier A-level analysis. We've proven to the examiner that we understand the why and the how, not just the what. You know what's really cool about this structured methodology? It perfectly mirrors something you already know: algorithmic thinking. Think about it: step-by-step decomposition, data structure selection, code implementation, and rigorous testing. When you're sitting there writing a PEAL paragraph, you are essentially decomposing the exam question step by step. You are deliberately selecting the right data structures, which in this written context are your technical vocabulary and your chosen evidence. You are then implementing the code through your written explanation, and you are testing it by linking it firmly back to the prompt to make sure it runs correctly. This strict procedural framework isn't just for essays. It extends to literally every part of the syllabus. For example, if a question requires data interpretation, like extracting permissions from binary representations, you don't just stare at it and guess. You algorithmically process it step by step right there on the page. And that brings us to a massively important piece of examiner intelligence, an absolute game changer. Listen to this. Even if your final answer is completely wrong, method marks can save your grade. In computer science, specifically in those tricky areas requiring calculation, logic gates, or tracing complex algorithms, the final answer you write on the bottom line is only a fraction of the total marks available. If you systematically process the problem, write out your intermediate steps, and show incredibly clear working, you build yourself the ultimate safety net. Let's say you make a tiny, silly arithmetic error on step 4 under pressure, but your logic was absolutely perfect through steps 1, 2, and 3. The examiner will still reward you heavily with method marks, but if you try to be a hero, do the math in your head, and just write down a final incorrect answer, you get a flat 0. So always, always show your algorithmic working.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Act 4, Interactive Workshop. It's time for some critical analysis.
Welcome to our 60-second data scan challenge. I want you to imagine you are in the exam hall. You turn the page and boom, you are hit with a massive, complex table showing adoption rates of various OSI licenses across different corporate sectors, alongside some incredibly dense binary data representing file permissions. The clock is ticking down. Your first instinct might be absolute panic. But using our strategic methodology, what do you actually do? You visually extract the core trend immediately. You do not sit there and read every single number like a novel. You scan for the highest delta, the biggest change, or the overriding pattern in the data. You identify those key elements, apply the relevant principles, and then, and this is the part everyone forgets, you rigorously verify your results against the data before you write a single word on the answer line. Time pressure constantly makes students skip that verification step, and that's exactly where precious marks just bleed away.
Now let's play Find the Flaw. I want you to listen to this piece of basic analysis and tell me what's wrong with it. Open source allows you to modify the code. Proprietary software does not. Did you catch the flaw? It's basically a glorified bulleted list pretending to be a sentence. To hit those higher-order assessment objectives we talked about, examiners demand justified recommendations and evidence-supported comparative analysis. True comparative analysis doesn't just list things side by side. It identifies similarities and differences simultaneously, and it explicitly uses comparative connectives. I'm talking about words like whereas, conversely, furthermore, or in contrast to. So a top-tier A-star answer looks more like this. Whereas proprietary software fundamentally restricts user modification to protect intellectual property, OSI-compliant software leverages user modifications to drive rapid innovation, thereby creating a vastly different product lifecycle. Do you hear the difference in authority there? That is how you command the examiner's respect and secure the top grade. Let's take this exact same mindset and apply it to algorithm evaluation. When examiners ask you to evaluate an algorithm, they are looking for very specific criteria to be addressed: time complexity, space complexity, edge cases, and overall performance effects. If we were doing a 30-second speed writing Peel challenge right now, your opening point wouldn't just be something vague like, this algorithm is fast. No. Your point would be highly specific. This search algorithm demonstrates high time efficiency, but poor space complexity. Then your evidence would cite the specific nested loop in the pseudocode that's causing the memory issue. Your explanation would detail exactly how that impacts performance when scaling up the dataset. And your link would evaluate if this specific trade-off is acceptable for the scenario presented in the question. That level of technical precision is completely non-negotiable if you want the top marks. We are entering Act 5, the final system and top examiner warnings. Let's pull this all together. I'm going to rapidly list the top 3 critical warnings extracted directly from the Cambridge Principal Examiner reports. You need to memorize these. Mistake number 1, using the wrong formula or algorithm for the specific context. Students constantly try to shoehorn an algorithm they spent hours memorizing into a scenario where it simply doesn't fit. You always have to match the tool to the specific problem they give you. Mistake number 2, forgetting boundary conditions and edge cases. When testing or evaluating a system, if you only talk about the happy path where everything works perfectly, you are throwing away massive marks. Examiners want to see you try to break the system, push it to its limits. What happens when the input is 0? What if it's 1,000,000? What if it's a negative number? And mistake number 3, arguably the absolute biggest killer on the entire exam: generic, non-contextual answers. If the answer you write could apply to any random company in any random situation, it is wrong. You absolutely must link your technical knowledge directly to the specific scenario provided in the exam paper. No exceptions. So, bringing it all together, here is your guaranteed exam success system in 3 simple executable steps. Step 1, command word decoding. The second you read a question, stop and circle the verb. Are they asking you to state, describe, explain, or evaluate? Your entire answering strategy hinges on that one single word. Step 2, Peel framework application. You never ever write a paragraph without a point, evidence, explanation, and link. It is the only way to force yourself to hit those high-value analysis and application cognitive domains. Step 3, time management matrix. You must allocate your time based exactly on the mark value of the question. Do not spend 10 minutes writing a gorgeous novel for a 2-mark question, only to leave yourself frantically rushing through a crucial 8-mark evaluation at the very end of the paper. This system, if you apply it consistently, will radically transform your software licensing and algorithmic problem-solving scores. And look, the data backs this up. Students who actually take this seriously, who consistently implement these exact strategies, moving away from raw fact dumping and adopting this Peel-structured, context-driven analysis, they see an incredible average improvement of 2 full grade boundaries. I'm talking about jumping from a C to an A, or pushing from a solid B up to that elusive A star. It is entirely possible for you to do this, but it requires deliberate, structured practice.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I want to leave you with this final critical thought. What is your actual target grade for computer science? And what is the absolute biggest challenge you are currently facing in getting there? Seriously, think about it. Whether you are studying the 9618 syllabus, or maybe you're tackling 0417, 0478, 0983, 0984, or even 2210, I want you to drop a comment below with your answer. By stating your goal out loud, you take the very first step toward actually achieving it. Our team reads and responds to every single comment. And hey, make sure to like and share this explainer with a study partner, because iron sharpens iron, and mastering your Cambridge success really is a team sport. Keep practicing that explosive, structured analysis we talked about today, and I will see you in the next session.